Good morning, all of you. I am Dhaneswar Behera, lecturer, Electronics and Telecommunication Engineering Department, Boscotter. Today we are going to discuss regarding digital circuit. So, in this chapter, we are going to discuss what is digital circuit, then what are the applications of digital circuit, that means in practical, where digital circuits are used, and then types of digital circuits and some expressions. So let us discuss digital circuit. What is digital circuit? So digital circuits are the circuits which works on a digital inputs. That means binary inputs. That means 0 and 1. That means these are the circuits in which they can capable to accept 0 and 1. Without that, they are unable to accept and they will give the error. That means a digital circuit is an electronic circuit that operates using discrete signals representing the information through binary values. Initially, I have told you that means it works only on digital data, that means 0 and 1. Then what are the applications? The major application is CPU and memory. That means in our daily life we are coming across our desktop, laptop. In that case, memory is present. In memory, your digital circuits are present. Apart from that, in central processing unit, also your digital circuits are used. Apart from that, in communication devices, like that means whenever we are using communication or we are conveying our message, the major application is smartphone or cell phone, where your digital circuits are also used. Apart from that, in industrial part, in automation, robotics, that means also your digital circuits are used. Then come to the types. Actually, your digital circuits are of two types. One is combinational logic circuit, another one is sequential logic circuit. So, what is combinational logic circuit and what is sequential logic circuit? Here you see. Let this is your combinational logic circuit. So combinational logic circuit means this is one type of digital circuit in which your present output depends on present input only. That means here, let this is the block diagram. This block diagram represents your combinational logic circuit where your present output depends on present input. That means whatever the inputs you are applying, accordingly it is processed and gives the output. That means the memory part, whatever the storage element we are discussing, it is not available here. That means in combinational logic circuit, your memory is absent. That's why whatever the output you are getting, that means according to the given present input. So if we will discuss or we will consider the sequential logic circuit. Sequential logic circuit. Here, what happens in combinational logic circuit? This is your combinational logic circuit, right? In combinational logic circuit, what happens? You are giving present input, whatever the input you are applying, and accordingly your output was produced. In case of combinational logic circuit, if in combinational logic circuit I am adding one memory unit, that means the entire system becomes your sequential logic circuit. Becomes your sequential logic circuit. That means sequential logic circuit is a type of digital circuit in which your present output depends on present input and past output or memory whatever stored. So what are the examples in combinational logic circuit? The examples are your adder, your subtractor, your multiplexer, your demultiplexer. So these are the examples of your combinational logic circuit. If we will go for sequential logic circuit, the examples are latch, flip-flop, shift register, counter. These are the examples of sequential logic circuit. So this is the basic idea about digital circuit and types of digital circuit, that is combinational logic circuit and sequential logic circuit. Let us discuss in detail. So difference I have already discussed in detail. So in detail, as the under combinational logic circuit, the example is your adder. So let us discuss adder. So what is adder? You know that a person who teaches is known as teacher. A person who paints known as painter. A person who drives known as driver. Like a circuit, a digital circuit which adds is known as adder. That is what it will add. It will add either your 2 single bit or your 3 single bit or more than 3 single bit. That means single bit means 0, 0 or 1 is known as bit. 0 is known as single bit, 1 is known as a bit. The combination of 0 and bit, 1 is known as bit. So here you see, if I am writing 101, that means it is a 3-bit data. If I am writing 1001, that means 4-bit data. So like that, it is considered. So in half adder, what happens? It adds single bit, that means 2 single bit, either 0 plus 0, this is single bit, this is single bit, either 0 plus 1, this is single bit, this is single bit, either 1 plus 0, this is single bit, this is single bit, either 1 plus 1, this is single bit and this is single bit. If such type of operation is happen, that is coming under half adder. Full adder, it is a type of digital circuit or combinational logic circuit in which it can add 3 single bit, that means 0 plus 0 plus 0, 0 plus 0 plus 1. So like this, if such type of operation is happen, that is coming under full adder. If such type of operation is happen, that is coming under half adder. So in detail, let us discuss half adder. So already I have told you, half adder means it is a type of combinational logic circuit in which it can add 2 single bit. So 2 single bit means, let us consider A and B are inputs. A is one input and B is another input. That means 2 single bit. So one is A, another one is B. And also let the output is S and C, where S is known as sum and C is known as carry. As addition operation is going to be happen, that's why in output we have to consider sum and carry. So whenever we are going to design a digital circuit, either adder, subtractor, multiplexer, counter, whatever, truth table is necessary. So that's why come to truth table. So here we are discussing half adder. Half adder means we are telling that it is capable to add 2 single bits. So that means inputs are 2. So if inputs are 2, then total number of combination equals to 2 to the power n, where n is the number of inputs, that's why 2 to the power 2, that's why 4. So total number of combination in half adder is 4. Then if we will sketch the truth table, here you see, so one column, first column represents the input column, second column represents the output column. Initially I have told you that inputs are A and B, your outputs are sum and carry. So total is 4. So that's why as binary data we are considering, that's why 4 divided by 2, that is 2. So in this way, 2 means 2 zeros, 2 1. Again you divide by 2. Result is 1. So in this way, single 0, single 1, single 0, single 1. Whenever we are going to add, that means 0 plus 0, your sum is 0, no carry. 0 plus 1, that means sum is 1, no carry. Again 1 plus 0, 1 inputs 1, sum is 0, carry is 1. In this way, your truth table is constructed. From the truth table, let us extract this sum expression. Sum means where your sum is 1, here the condition, where sum is 1, here another condition, where sum is 1. So, this is the condition sum is 1 means what are the inputs? A is 0, B is 1, that means A is 0 means A complement, B is 1, that means into B. Again, another condition is also there where your sum is also 1. So, A is 1, that means A, B is 0, that means B complement. In this way, this is nothing but A exercise. So, in half order, we conclude that your expression for sum is A exercise. So, again, come to carry expression. Carry is C. Carry is, so this is the carry column. In carry column, this is the condition where carry is 1. So, carry is 1 means, so what are the inputs? A is 1 and B is 1. So, that's what A into B. So, in this way, so these are the expressions for sum and carry. That means in half order from truth table, we conclude that your sum is A exer B, your carry is A into B. So, whenever we will sketch the logic diagram, that means by using logic gates. So, your two inputs, one is A, another one is B. So, your expression is A exer B for sum. So, that means this is your nothing but this is your exer gate. That is A exer B. Another one is exer B. Another one is your carry is A into B. So this is your A line. So that's why I have taken A line. That means A input is flowing. Another, this is your B line. So B input is flowing. A into B, that is product operation. If you will consider AND gate, then product expression can be obtained. So that's why this is exer, this is AND. In this way, your circuit diagram or logic diagram is designed by using two inputs. One is A, another one is B, and expression output is sum and carry. Where sum is A exer B and carry is A into B. This is regarding half order. So that's all.